Hey everyone, how are we doing? It is Wednesday morning. Oh my gosh. Oh my gosh, I gotta look at my fantasy. How's everyone doing here? Who do we have watching? Do we have anybody? I'm gonna go look at fantasy football here. It's sports day. Sports. If you're in the chat, feel free to say hi. Brian's starting up here by looking at some of his sports. I made 2 trades. Did either of them go through? I think I got rid of one of my quarterbacks. Had 2 quarterbacks. And I got rid of. Does that show my? Look at my score right there. Charter projected. I'm projected to lose this week. I won last week. If you're in the chat, feel free to say hi. Brian's gonna look at his fantasy team right here and see how they're doing. Trogdor. Did either of my transactions go through? My league. I need to go look at the league. League home. There's league home. Let's see who did what. Trogdor made 2. Ooh, both my trades went through. Oh, there was 5 transactions yesterday. If you're in the chat, feel free to say hi. I think we're streaming to the internet. I dropped Dawson Knox and got Gerald Everett. And I dropped Dak Prescott because he got injured. And I've got Tom Brady, so I'm going to play Tom Brady like he's, I don't know. And then Jameis Winston. He did really well the first week. He's, maybe he'll be the, phenom this year. I don't know. Find out New Orleans Saints looks like. So we'll see how he does. Just kind of hang on to him a little bit here and see if he becomes a rock star. So we want, if you're in the chat, feel free to say hi. We're here just going to take questions and see what people were wondering. Keenan Allen is out. What? Brady's projected to get 21, and my other guy's projected to get 17. We'll see how my team does. I think I've got everything looking good right here. Brian's fantasy team. Hey, it's just someone in the chat right here. Blake, good to see you here. I'm looking at my fantasy team, Blake. So I'm they're doing I've got DeAndre Swift. So I've got DeAndre Swift who did well last week. I've got AJ Brown did all right. I've got decent players. Jalen Waddle did all right. How's your fantasy team? Or let's see here. We got Mewbot waking up. Feel free to say hey in the chat. And whatever question people want to do, we're just here to do some work in the morning office hours. So yeah. Already played that one. I need to set all the music to one thing. But here's my fantasy team. I don't know. Let's go check out Brian's fantasy team. We'll put a link. We'll put a thing in the video here. Brian's fantasy team. Brian's fantasy football team. What do you got? I'm already qualified to talk about college basketball. I'm really only maybe college football. Here's my team right now. I got Brady. I had Dak Prescott, and I just dropped him because you only need 1 QB. I mean, you got your bye week, but Brady should hopefully do all right. So I got Brady. I've got Eckler. I've got Swift as my RBs, my running backs. Got Brown, Waddle, Cooks. Then tight end. I mean, it's not really good. I think I picked up a new tight end. I picked up Gerald Everett, who did really well last week. I mean, you don't know at the start of the season. There's just think about what's his name, running back a few years ago. Had a insane season, but just had a really short. I don't know. NFL careers are interesting. Especially if you're in a position where you could get hit a lot. Oof, I wouldn't want to do that. Thinking of the guy who played for Tennessee. Tennessee running back, went to the NFL, had a breakout season 2012 or 2013. NFL running back. Maybe someone remembers the name. Once I hear it, I'll be like, oh yeah, Foster. Arian Foster. There we go, Arian Foster. Arian Foster, really awesome guy right there, and really just great running back. So it was it'll come to me. But it had breakout season, so you don't know who's gonna have a breakout season. So I'm kind of shuffling around some players. I added 2 players yesterday. I dropped Dak Prescott and dropped someone else, and got Gerald Everett as a tight end. I mean, I don't know, he might do something. And then I got the quarterback. Who's my other quarterback now? James Winston. So we'll see how he does. We'll see. I don't know. Brady up there in his 40s, like me. Brady, we'll see what Brady does. But I had Dak Prescott, and so I won my first week. And so there we go. I'm playing against the Charging Buffalo right there. Won my first week, 76 to 89. Pretty good right there. Hey, Victoria, what's up? What question should we work? We're just looking at Brian's fantasy team right here. It looks like we got a game on Thursday. Gonna have him right there. So Austin Eckler better do well on Thursday. Oh no. there was like a old ESPN commercial where someone's like bagging someone's groceries and they were just like tossing stuff in and they were like, yeah, so you can't catch the ball. And he's like, the guy's like, I'm sorry, my team still won. And they're like, yeah, but you didn't get points. It's like fantasy changes around the game. It makes it interesting for someone like me because it's actually like you're playing. So I think they were smart to make up, fantasy football. I guess, I don't know, when did fantasy football come out? Like early 2000s? Like when did fantasy football become a thing? I know I first started hearing all about it like 2010, 2011. But I wonder when the first like fantasy football team was, like when people were like drafting their own players. But whatever question you have, we can do it. I have Rodgers. He had 3 points last week. Oh no, Aaron Rodgers really had that crazy of a week, Avery. Oh no. Who is the best QBs? Who are the best QBs right now in the league? I mean, Brady, what he had? He had 12 points last week. It's not a lot. I mean, but that's not horrible. I had a guy get -5 last week or -3. Must have got sacked, or it wasn't a QB. It was one of the running backs got like -3 or something. I think I dropped him. I mean, not that I would drop. I mean, everyone can have a bad week, but he was someone on my bench who got -3, and I was like, yeah, you're gone. You're gone. Oh no, it's James Cook's -2 right there. There he is. So -2, but I mean, he stayed 119th. So I don't know. Things start to stabilize after a while. You don't know what things are going to be for quite a while when you're watching fantasy. Someone has a good bad week. Allen points wise, I think. Oh really? Allen point. Oh yeah, Josh Allen with the Buffalo Bills, right? First game of the season, just exploded with like 30-something points or low 30s. Hey Taylor, good to see you here. We can work whatever question. Just drop the questions in the chat. I'll go back to the main screen. See, I should put up my taking questions thing so people know. But we were just on some fantasy football getting started. Some football. Are you ready for some football? Just chilling out here doing some work, but whatever you want. Chapter 4 for Stat 201, 474 doing for loops or while loops, 320 doing associate functions. What shall we talk about? You name it, we'll talk about it. Chapter 4 quiz. Let's look at some Chapter 4 quiz. We got a bunch of new questions this year. So even I got to be like, what are the new questions? Which one are you working on? Chapter 4 quiz. Play one more song right here to get started right here. I'm going to pull up some Chapter 4 quiz. Chapter 4 quiz. Also, a study reports load factors. Passenger miles is percent miles. Oh, cool. Victoria says, yep, that's a good one. That's a good one right there. Let's go grab that. Thank you so much, Mary. You can drop the questions anytime right here. Chapter 3. Oh, do you want to do the Canvas content quiz? Is that the Canvas content quiz, or is that, Taylor, which one is that? Is that Pearson or Canvas content? Because that sounds like Pearson. Off the top of my head, that sounds like a Pearson question. So let me know, is that Pearson or Canvas content? Stat 201, Chapter 4. And then, Taylor, if you want, or Victoria, we could do it's Pearson, that's what I thought. We could do the Canvas content if you want. We can do the Canvas content. Well, also feel free to jump in anytime if Brian's talking fantasy football or whatever and be like, hey, can we do this? But I love everything. Everything is like analytics related. Like fantasy football to me is all analytics. It's all numbers. It's all just I don't do it because I like sports. I do fantasy football because I like competition and I like analytics. So I like running the numbers. I don't really care about the football side. It's sad. Like a team wins and I'm like, oh cool. All right, let's hear it here. Okay, let's take a look. Start reports faster. Okay, I think we got it right here. So the time is 11:05. Let's do it right here. Okay, the Research and Initiative Technology Administration, such and such, for commercial airlines for every month, reported the data. The accompanying histograms show the load factors for September through March versus for April through August. We got September to March, that's like the winter months, April to August, that's the warmer months. Compare and contrast the histograms shown. Okay. Okay. Histograms display what kind of data? Oh, we can do it here, student Victoria. You got it. Histograms display what kind of data? These are stacked histograms with the same horizontal axis. We should know that right here, that whenever you display stacked histograms, you do the same horizontal axis. So this is, they're looking at number of months, and this must be over multiple years. You got 2002 to 2017 or something. There, it's in the chat. 2000 to 2019. So this is multiple years, and we've got like the winter months right here, September to March, so the colder months. We've got the warmer months right here. So what kind of data do histograms display? What kind of data does a histogram, a singular histogram, display? A singular histogram displays what kind of data? So this is where you put Q, C, or I in the chat. Does a singular histogram display quantitative, categorical, or identifiers? Does a singular histogram, good review of our knowledge right here. Does a singular histogram display quantitative, categorical, or identifier data? What does a singular histogram do? And I'll show the cheat sheet here in a second, but I want you to see if you can answer C, Q, or I in the chat. Don't worry about getting it wrong. Just remember to practice. So you have to be like, a histogram displays this kind of data. A histogram displays what kind of data? Oh, Blake, no worries, Blake. 100 points. Blake's just here for those wacky Wednesdays. A singular histogram. This is why we practice after Crash goes away on these wacky Wednesdays. A singular histogram displays what kind of data? A singular histogram displays what kind of data? Use the cheat sheet now to help out. A singular histogram displays what kind of data? This is why we practice it. I ask the questions a lot to be like, okay, a histogram displays this kind of data, and you have to be like, and so a histogram displays what kind of data? A singular histogram. A singular histogram. Quantitative, great job there, Blake. So a singular histogram displays quantitative data. Now you can do stacked histograms, which you see right here, where you're adding in an X variable, you're splitting it apart. Histograms are still quantitative, like you're still doing quantitative data with histograms, but you're just doing two histograms. So you have like group A histogram, group B histogram. So that's like the categorical part of it. So that's why it's two variables now. It's a categorical X and a quantitative Y. Histograms are still always quantitative Y variables, but then you could split them apart into two groups right here. So when you look at this, this is what we call stacked histograms that have the same horizontal axis. Make sure to have a note card or a flashcard that says histograms display quantitative data. Now, stacked histograms are a bivariate display which have a quantitative Y. We're understanding number of months. So we're asking how many months are in this group. And then right here, we are asking, or so we're not asking how many months, we're asking a load factor, which is the amount of the load factor. And with this right here, you can see that the April through August has more months at the higher values. So this is definitely, April through August is definitely more of a what skewed distribution. April through August is definitely more of a what skewed distribution. Now they both look to be this, but April through August is more of this. They both look to be it somewhat, but this one's even more. Random call. They're both what skewed. So what way are these skewed? They're left skewed. Kylie, great job right there. And let us know if you have any questions. They're left skewed. Now, this one right here has a higher center. And this one's a little bit lower. So we can figure out where the centers are at, which would be represented by the medians. The spreads would be compared via the IQRs. So let's see what the answers say. We kind of got some notes for what we drew right here on how these look. The distributions are unimodal and skewed to the left, so it has to be one of these right here. The fall and winter load factors appear to vary more. So the one that's going to vary more is going to have more spread to it. So let's see right here. It's going to be spread out more. Let's see. So which one varies more? This one right here. Wish I could just run the data. This one has a bigger range up here, the top one. So this is the September through March. It has a bigger range, and range is usually a good indication of spread. So let's go right here and say September through March. September through March is going to be the winter ones, right? So I wish they just said that. So the fall, winter load factors appear to vary more than the spring, summer. Yeah, it'd be spring, summer. Okay. That looks to be it. Woo! Good question. I wish they just said the months up there. But does that make sense how we looked at this right here? The way I could tell which one had more variation, I can just kind of look at the range. You don't always, they're both left skew, but the fact that this has more of a range, since they're both left skew, this one's a little bit more skewed, which does indicate a bigger spread. But this one has a larger range, and that indicates more of a spread to the data too. So I'm going with this one being more spread out across the axis. Just a little bit more. They're both left skew. This one has a higher center. This one has a lower center. We should use the median to compare them and the IQRs. I wish we could quote those numbers. And we could see, yeah, the range in the middle 50% of here is even a little wider than this one. This one has a smaller range of middle 50%. I don't know exactly where the middle 50% is, but if I were to guess, so we're going to do Canvas content after this, but we are open for questions. Please let us know what your questions are. And I'm just right now pretending I can figure out where the middle 50% is, because if you look, if we do about 50% of the data, the top one's going to have a bigger spread to the middle 50%. I might have even covered more than 50% of that, and that one might be a little bit more too, but if you notice, the top one is more spread out on what I estimate to be the middle 50%. So definitely a larger spread to the winter months up there, which covers September through March. So, and I wish they just said September through March months, not the winter. They're making you know your months of the year. Oh my gosh. Canvas content coming up. But remember, we do the questions you ask. So if you're here, I have a question with part 2 for the 474 homework. Avery, what would you like to know? Can you the one that starts out the same but is about box plots? Oh yeah, let's see. There's a box plots one? Let's do that one. Let's throw that one on here. It starts out the same, Kylie says. It has box plots. Okay, let's find that one. We'll mark it as like the box plot version. It's a good spot right here because someone else might be looking for that. And then let me know about number 2, Avery. Okay. Ooh, I like this. So we got a study report, solid factors, same one right there. Taylor puts. Yep. Okay, so we might have done, here's a histogram version. And then we're gonna do the box plot version right here. So we're putting in the box plot version. Box plot. Oh my gosh. Box plot version. Okay, let's do this right here at 1903. Here we go. Let's do it. We got some more stuff right there. Good questions, Avery. So this one right here is the same sort of question we were just doing a moment ago, but it's going to use box plots. So let's look at this right here. Side-by-side box plots. Well, let me ask you this first off. A box plot displays what kind of data? A box plot displays what kind of data? A box plot. A singular box plot displays what kind of data? A singular, is it quantitative, categorical, or identifier? A singular box plot. These are things we have to know pretty quickly. They're really good practice. Quantitative, great job, Taylor, right there. That is correct. A singular box plot displays quantitative data, as you can see up here, a singular box plot. Now you can do what's called side-by-side box plots, which is going to break it apart by categories. And that's what you're seeing right here is what we call side-by-side box plots, where it's still a quantitative Y. You see it's like on the Y-axis because the vertical right here is the Y-axis and the horizontal across the bottom is the X-axis. And that's what I'm pointing to right here because the categorical X is categorical. Well, this way right here, that way. And you can see right here with the side-by-side box plots, the Y is quantitative. If you trace this way right here, you can see we're doing a quantitative Y. That's how to read this graphic that's currently on the screen. So with this in mind right here, we're looking at the year and the trend across year. And you can see that the load is getting wetter as year increases. As year increases, oh, and the box plot gives you the 5-number summary. Exactly, yeah, that's the min right there. That's the Q1 is the bottom of the box. The median and the Q3 and the max. And you have to watch out because sometimes box plots can be weird. In this instance, the min and Q1 is the same. There's the median, there's the Q3, and also the max for group 2, year 2. Looks like they didn't include year 1. I don't know why. I wish they did. But you can see we have outliers sometimes. Do not forget outliers because this would be the minimum down here. Remember those outliers, and this would be the maximum. That's the Q1, that's the median, that's the Q3. The line right there, which is called the whisker, is the lowest point that is not an outlier. So that line right there is the lowest point that is not an outlier. Okay, so we understand what we're seeing on the screen. We have side-by-side box plots up top, and then we just have a box plot of all the data right there. Okay, outliers are context dependent. What is the question asked? The box plot for each year shows the same data, but the outliers, yes. What do you think? What do you think this is? Outliers are context dependent. Data values that seem ordinary when placed against. Oh, why do you think this is that there's an outlier? Okay, yeah. So the reason that there is an outlier, there are more outliers down here, is because the way in which we calculate outliers is outliers are how far below Q1 right now. This is where Q1 is. Outliers start how far below Q1. So outliers start how far below Q1. So there's a distance that we should know and memorize. Starts off 1 point something, and then it's IQRs. And you can see it. We can do it here visually. So the outliers will always be this many IQRs. We can show it. If we take the data right here, let's go over Microsoft Word. Outliers are 1.5 IQRs. 1.5 right there, Keith. They're 1.5 IQRs below Q1. So if we were to go here and take this right here, which is the IQR. Ooh, it made it bigger. We don't want that. So we need to make it about the same size. It's behind it now. It's close enough. If you look, 1.5. And look at that. That's where that line is. It's about 1.5 right there. And that's where that line is. 1.5 IQRs is where. There it is right there. Place putting in the chat. That's where we draw our invisible fences. That means there's an invisible fence up here. But why don't you see any outliers? That there wouldn't be outliers there. But why don't you see any outliers on the high side? We don't let you see the invisible fences afterwards, but they're drawn in there to tell us where outliers begin. And it's because there are no outliers on the high side. This right here represents the highest data point. That would be the max. But this is not the lowest data point. That is the lowest data point that is not an outlier. This right here is the minimum. That's where people make mistakes. You don't get to see these invisible fences that are calculated 1.5 IQRs below Q1 and 1.5 IQRs above Q3. Now, it's context dependent where we calculate it because we have to figure out where Q1 and Q3 are. So that's what this question is getting at, that when you make a bunch of box plots, well, a bunch of box plots are going to have different calculations for where outliers are. This one calculates them to be here, where this one has a much higher calculation where that invisible fence is. So let's take a look at this. Outliers are context dependent. Okay, well, that's the answer. Data values that seem ordinary when placed against 1 year's data may stand out when compared against the entire data set. That sounds about right. Data values that seem ordinary when placed against 1 year's data may stand out when compared against the data for another year. Data values that may seem ordinary when placed against the entire data set may stand out when compared against the data for 1 year. Let's look at these two real quick. Data values that seem ordinary when placed against 1 year's data may stand out when compared against the entire data set. I think that's what they're getting at right there. Yeah, that is such a weirdly worded question. I mean, I know what they're getting at. It's just that they're not giving you enough details on it. I wish they gave more details on it, because what they're getting at is when we calculate where outliers are, we have to do the calculation on where, and we'll take another picture. The calculation would be based on where is Q1, which it's right there, but over here, Q1 is here, and then we'd go down 1.5 IQRs. So for that box plot I'm tracing up there, this is where the fence would be, about there. The fence would be somewhere there, and there are no points down there, so there are no outliers. But for this box plot, we go down 1.5 IQRs, and that's where the fence is. You also go up 1.5 IQRs, and the fence would be up here, but there's no data there. Now, we don't keep the fences, but that's what they mean by context dependent. So for this particular box plot right here, I'm pointing to one that does have an outlier. The fence has to be somewhere here, and we don't see it, but the fence has to be somewhere in there because we have a point that's outside the fence and thus denoted as an outlier. So when we do the calculations for each individual year, we get totally different fences than we would for all the data together. So there might be a point up here that stands out by itself, But when we do the calculations of all the data, the way the fences are calculated are going to make different points stand out because there's different context to the full data set versus the individual year data set. So the big number to know, especially as we review this, is the 1.5 IQRs, and that would either be Q3 plus the 1.5 IQRs, and that's when you go above the upper fence, which is this way, or if you go below it, well, then the lower fence is going to be Q1 minus 1.5 IQRs. And this 1.5 is a huge number to know, 1.5 IQRs, which the IQR is literally this right here, the length of the box. So a lot of good review right here, but trying to expand beyond the question. Don't just look at these questions as like you get it right and then you know it. You need to understand like what is the IQR, what is Q1, what is Q3, how do we calculate where the fences are at. So we talk a lot of the theory here when we do the question. So good review. Let's do some Canvas content. Good questions, everybody. Keep dropping those questions in the chat. Look at the way the wording on that. Oh my gosh. The wording. Let's do some Canvas content. What does this Canvas content do? So we just had one. Let's see. How is everyone doing this morning? Throwing out some more MuBot points. Data Analytics 2 should be graded here soon. We got almost all of them graded. Let's see. Canvas content due next Monday. I like that. I like working on these early. Let's see. Canvas content number 2. Canvas content. Right, Stat 201. Number 2. Chapters 3 and 4. We'll do 2 versions of it. Chapters 3 and 4. Here we believe it too late. I know. I'm doing well. Thank you, Keith, right there. A National Vital. Roshni wants National Vital Prize information about age, sex. Oh, we'll do that one here soon. Let me take that right here. And then I think we got a 474 question next. The 474 question was question. Avery says, the message, I'm not sure to break down the open variables, so let it break down by month. So 474. Monthly paying off car loan. Okay, so let's go ahead and let's preview this. Let's do it. Okay, we got some Canvas content on the screen here at 29:23, and let's take a look. When comparing histograms, they should have the same horizontal axis. What are your thoughts? True or false? Remember, these are great things to put on flashcards and see if you know them. When comparing histograms, they should have the same horizontal axis. True or false? We were just doing a question like this a moment ago, so I review these things and say, like, here's what we need when comparing histograms. Check out earlier in the video where we were doing 1105 right there, the first question. It did cover this, so that is very true. Great job, Victoria, right there. That is true, and great job working on this. What is the 75th percentile for the French team? So the thing to know is, you're looking for the what of the what. When I say the 75th percentile of a box plot, what are you looking for? So you just want to, don't think of this as just one question. Think when it says 75th percentile, you need to know where you should be looking. It does say for the French team, but what is the 75th percentile? It might be, I think you're right. It's Q, well, that is Q3. So that means it's Q3. We call that Q3 because 3/4. And so theoretically, where is that always at for a box plot? I think people are right. It probably is going to be 190. Great answers in the chat. Where is that always theoretically at for a box plot? Which I think you know it. Just like be like, oh, was this spot on a box plot? Where is Q3 always at? This is the knowledge to always solve it correctly no matter what. Q3 is always where on a box plot. It's always the what of the right line on the box, the top line, right? Great job, Victoria, right there. More points in the chat. It's always this right here. So that is Q3. If you want to practice, try labeling your points like Q1. Oh my gosh, look at that. I already made a mistake. My brain was like, wait, what are you doing? So this is the min. This is the Q1. This is the median. This is the Q3 right there. Now I want someone to scream at me. Someone watch out. What mistake did Brian make? This is a classic mistake right here. The answer to our question is 190. That is our question answer because it's this. That is Q3 right here. What mistake did Brian make labeling that box plot, which is a classic mistake? I'm doing some box plot coverage right here. What classic mistake did I make over there? What classic mistake did I make? Very common mistake. A lot of students make it. Probably the most common lost points during the test on this. So look at what I've done over there. The max is the outlier, Victoria. That's totally right. Don't forget. I have students who go, oh my God, but can't. I know it. They say, oh my gosh. And I'll do it sometimes too. I'll make that mistake. This is the max. This point right here is the highest point that is not an outlier. The fence is somewhere probably in here. We don't know where that imaginary fence is at. You don't see it. But there's some fence that divides, you know, there is data up to this point, and that's right here. There is data up to here, but then there's a gap in the data set right here. So there's just a big gap in the data. So that point right there that I've highlighted is the highest point that is not an outlier. And then the maximum is that point that's up top, and it is an outlier. So the answer is 190 to this because of the France right here having Q3 right there, and you could figure out the other ones, but that one's an obvious one because it's right on the line. We try to make things a little bit obvious. Below is a contingency table. A contingency table displays bivariate what data? A contingency table displays bivariate what data? The answer is on the screen along with a mosaic plot. A contingency table displays bivariate what data? These are the questions you always want to practice answering. See if you can answer them out loud. Your friends and family might think you're crazy. Great job, Victoria, right there. Shout it out loud for everyone to know. Sing so everyone can hear you. It's bivariate categorical. So what % were neutral about the chocolate they tasted? Okay. So what % were neutral? And oh, so this is a marginal display. Okay. So right here, we're asking what % of the people who tried the chocolate were neutral. It doesn't ask about another variable. It's just asking about the neutral. Gotta love that right there. A little extra artifact. Would you? I think so. Great job, Victoria, answering it before I can, doing the marginal display. That is right, because we're just asking about the one variable, and that is a marginal display. Victoria, you're just doing awesome today. Look at that. Victoria, 500 points. Remember, if you're here talking, you get those points. So shout outs to Victoria and everyone else who's been talking today. Amazing work, Victoria. That is a marginal display, and we're just going to take and do the mathematics, just like you said right there. 229. We'll do another version of this also, but great job. Marginal display. Make sure to enter it in properly as a decimal. If you feel like it didn't count you right, even though you entered it correctly, let me know, because we shouldn't be taking off points for the... I think I've corrected all these to not... It says to enter it this way, so enter it this way as a % without the sign. But if for some reason it doesn't say you're right and you entered it as a decimal, it doesn't matter. But try to follow the format. What is the probability of a student being born in Tennessee? Once again, we have a marginal. Oh, 2 decimals. Victoria, you are doing a great job right there. We have a plus or minus on it. There we go. That should do it. Great job, Victoria. I was just testing to make sure you're watching. What is the probability of a student being born in Tennessee? Is this a marginal or conditional display? Now, marginal means we're just talking about one variable. So now I know there are 2 variables here, but I'm just asking you, what's the probability a student is born in Tennessee? So does that sound marginal or conditional? Hey, Taylor, I'm right giving shouts right there. Does it sound marginal or conditional to say, what's the probability a student is born in Tennessee? Don't worry if you get it wrong. I'll tell you why it's the answer no matter what. Does that sound marginal or conditional? It's marginal, Keith. No worries, it's marginal. Like if I said, what's the probability of an honors student being born in Tennessee? That would be, given they are an honors student, the probability they're born in Tennessee. That's conditional right there. Like, given someone is an honors student, what's the probability they're born in Tennessee? But if I say, what's the probability a student is born in Tennessee, we'd be looking at just this right here, which is just the values in the what. Think about why it's called a marginal display. It's just the value in the margin right there. So if it were to ask student born in Tennessee and is honors, so, well, that sounds conditional, right? Victoria, do you hear yours right there? Yours might say something like that. It says, what is the probability a student is born in? What's your question say? Can you copy paste the question in the chat, Victoria? If highlight this right here, like this, Victoria. Hey, PJ, good to see you here. Yeah, congrats. Hey, let's throw 1,000 points for PJ graduating right there. Copy paste your question. PJ, so good to see you. Yeah, I do remember your name. I remember PJ Tall. I remember that in the chat. So good to see you. And still a mod here, of course. So thank you so much. Congratulations. Below is a contingency table by the where by whether they were by where might be a typo. Born in Tennessee, not you, but us. And whether they were an honor student. What is the probability of a student born in TN being an honor student? So it's not what is the probability of like both occurring? What is the probability? It says, so what is the probability of a student born in Tennessee being an honor student? So Victoria, what would be the mathematics here? So there's the conditional distribution. What is the probability of a student born in Tennessee being an honor student? So if your numbers are the same as mine, that would be it right there. You're welcome, PJ. Congratulations. This is for you. Well, you're graduating in December, you said? So yeah. Oh, you graduated in May. I graduated in May. Okay, you'll be graduating. Not out of 923, out of 574, because that is, so you see how I've circled this? I've circled only the students born in Tennessee. Does that make sense? So what is the probability of a Tennessee student who was born in Tennessee being an honor student? Out of the 574 Tennessee students, 50 of them were honor students. So there's 574 students born in Tennessee and 50 are honor students. So this is why we call it conditional. Conditional looks within one of the variables. So yeah, good job, Victoria, right there. This is the practice. Think when you do a conditional distribution, you're setting a condition for one of those. So 50 out of 574. Yep. That's a good question right there. So that would sound like, out of all the students, what is the possibility of someone being born in Tennessee and being an honor student? It sounds, you have to say it, the wording, you got to watch out because it can sound very similar. Like, what is the probability of someone being born in Tennessee being an honor student? What is the probability of someone being born in Tennessee and being an honor student? So here, I'll write them both down for you and you can hear the I do admit, they're very small differences. Are you ready? Conditional. You might think I'm saying the same thing. What is the probability of someone being born in Tennessee, someone who is born in Tennessee being an honors student? And then this would be all data. What is the probability of someone being born in Tennessee and being an honors student? Okay, so here's the difference right here. What is the probability of someone who is born in Tennessee being an honors student? What is the probability of someone being born in Tennessee and being an honors student? Does that make sense? Because this is saying of only the students who are born in Tennessee, what is the probability of someone who is born in Tennessee being an honors student? So that's conditional. Like if they're born in Tennessee, what's the probability they're an honors student? And if you're doing from all the data, which is when you divide by 923, what is the probability of someone being born in Tennessee and being an honors student? Not like of the students who are born in Tennessee, but what's just the probability of these two combinations occurring at the same time? Does that make sense right there? Like it's very small, but the first one is asking like of only the students born in Tennessee. And so if you look at the wording of, I'll copy Victoria's question like verbatim, and then we'll try to find the exact wording right here to hopefully let everyone see. So what is the probability of a student born in Tennessee? So right here, this is setting the what for you. What is the probability of a student born in Tennessee? That is setting a what for you. Yeah, exactly. And so do you see this? Think of the words we use with marginal and something. What is the probability of a student born in Tennessee? So it's saying of only the Tennessee students. That's what that's saying right there. It's like given, I like to say given a lot of times, like given someone's born in Tennessee, what's the probability of this? That's setting the what for you right there. So what is the probability of a student born in Tennessee? That's setting, think of a C word. That's setting the what for you right there. That's why we call it this. That's setting the what for you. And that's why I think I've still got the picture right here. That's why it looks mathematically like this right here. So this is how this one should look, because this right here is setting the condition. It's the condition, no worries. That's the condition. What is the probability of a student born in Tennessee? So only the students who are born in Tennessee. What is the probability they're an honor student? So I'm circling only the students born in Tennessee. So what is the probability of a student who's born in Tennessee? So these are the only Tennessee-born students. Being an honor student, it'd be 50 out of 574. But then the reverse of it would look like a combo where you say, in this one right here, if we did all the data, what is the probability of someone being born in Tennessee and being an honor student? If it contains the word "and," it would mean they are. You have to be very careful. These can be tricky. We'll do a few more. This one right here is what is the probability of this and this occurring? It doesn't say of only, or I know the other one doesn't say of only. Like the best way to word this would probably be like, I'll make this super cool with my wording now. If we only consider the students born in Tennessee, what is the probability they are an honor student? That's super clear. If we only consider the students born in Tennessee, what is the probability they're an honor student? So that's what we're getting at. I'll show you the other one. So you can see the super clear wording and the original wording of it. What is the probability of a student born in Tennessee? So that means if we only consider students born in Tennessee, that's where the condition's being set. What is the probability of them being an honor student? So right there, if we only consider students born in Tennessee, which is what this is doing right here, what is the probability of them being an honor student? So what is the probability of a student born in Tennessee? So we're only considering those students. Does that help, Victoria? This is one of the tougher parts of the chapter and where a lot of mistakes are on the test. But you have to understand right here, if it's asking this, what is the probability of a student born in Tennessee? It's only asking this, being an honor student, like only Tennessee students, only Tennessee-born students. Awesome. We'll try to do another one of those. There's a chocolate one that usually people miss. I'll make sure we get that one in this video. What is the probability of a student being born in Tennessee? That's just going to be out of all students born in Tennessee, 574 divided by 923. That's going to be that right there. Copy, paste over. And then we just want to go to the decimals. There we go. Below is a contingency table. Oh, do we have the same one? What is the probability of a student born in Tennessee being an honor student? There we go. And we were just doing this one a whole bunch of times. So check out where we were just solving this right here. Watch me get it wrong. That'd be awesome. And there's the answer right there. And it says to 2 decimals. And so we'll do another version because there's a chocolate one that I can knock out. Submit the quiz. Hopefully we didn't make an error here. Woo! I get so scared because I can misread questions. It happens all the time. Let's make sure we get that chocolate one in here. Because the chocolate one is one that catches people off guard. What percent? Oh, maybe we removed it. There's the superhero one. But where's that chocolate one? Is it going to give me the same preview? It might have. Here, I'll submit the quiz. I might do the superhero one if we don't get the chocolate one. We're going to see I got some zeros. Could we do the superhero one? Yeah. I'm gonna remove that chocolate one. Oh yeah, I'll try find a version that has the superhero one again. So we'll either do the other chocolate one or the superhero one. Okay, wait, here we go. Here's the superhero one. Is the chocolate one number 4? That's the chocolate one, but there's another chocolate one people get wrong. It's like of the extreme dark chocolate. It's a conditional one that people get wrong a lot of times. So let's do this quiz version right here. Which of the following is a bivariate display of categorical data? Which of these right here, A, B, C, or D? This is one we should get pretty quickly. Which of these is a bivariate display of categorical data? So 2 categorical variables is A, B, C, or D. Which of those is the right answers? Which of those is it? A, B, C, or D? Bivariate categorical. And the hint is on the screen right now. Bivariate categorical, is it A, B, C, or D? And you can see the answer in the bottom right corner, where we have 2 categorical variables can be used and displayed howly. A, B, C, or D. I need everyone's help here. What do we think? Is it mosaic plots, histogram, stem, and leaf? It's mosaic, which also go along with, great job right there, Roshni, which also go along with contingency tables. And we can see a mosaic plot down here. That's a contingency table, but it could be made into a mosaic plot. Box plots. So box plots, plural, are not ideal for comparing multiple groups. Box plots. Now, this is a key thing I've had students get wrong before because this is plural. So box plots means we could do side-by-side box plots. That's box plots plural, not a box plot. A lot of times students have said to me, wait a minute, that says box plot. Well, we're talking multiple box plots, not a singular. So this is going to be false right here. Box plots can compare multiple groups. We did my Pearson question just a moment ago, and you can see right here, a singular box plot, that's a box plot, doesn't compare multiple groups. Box plots can compare multiple groups, so definitely they're not ideal. No, they are ideal. They're actually very ideal for comparing multiple groups. So box plots are ideal for comparing multiple groups, so the not right here is false. This is the superhero one. What percent of Marvel superheroes? Does this sound marginal or conditional? So this says of the Marvel superheroes. This one's a little bit clearer. Does that sound marginal or conditional? So let me know in the chat, marginal or conditional. If we say, what percent of the Marvel superheroes? Does that sound marginal or conditional? When I say what percent of the Marvel superheroes? So I'm going to give you hints right here while I draw on it to help out. What percent of the Marvel superheroes have the ability to fly? It's conditional. Great job, Blake, right there. That's setting a condition, looking inside. So great job, Victoria, also have the ability to fly. So what's the mathematics going to be on this? So of the Marvel superheroes, or given someone is a Marvel superhero, what's the probability they can fly? This is going to be a conditional display right here where we go within one of the variables. It's the same as the earlier question where it's looking at the Marvel superheroes. Oh, yours is? Do you get yours, Victoria? And so what would, yep. Not out of your numbers might be that. Mine's out of 794. I think you just reversed the number right there. Yep. So I think you have it. It's 794, right? I think you just transposed the number. So divided by 794. There it is right there. Make sure to do your decimals. It wants it as a percent. Always check. I make errors too. If you feel like you make a math error like that, let me know. Now this one right here is the neutral about the chocolate they tasted, which is the marginal display. We did this one earlier. We might have removed that chocolate question. I liked it. And this one says a decimal too. Oop. Yeah, no worries. 100 points. Sorry, I was about to join and ask about quiz 4. You ask away. We got some more time right here. We got time to do a few more questions. What is the probability of a student born in Tennessee being an honor student? We did this one earlier. It's conditional. Given someone's born in Tennessee, what's the probability they're an honor student? Watch out. Make sure when you're doing this, you realize it's saying, what is the probability of a student who's born in Tennessee? So only the Tennessee-born students, which would be this right here. Then we take the number, we move the decimals, and we get the following. That should be right. Hopefully we moved all our decimals, and check out earlier where we did a more in-depth conversation about it, and we did it. Let's see if we get another thing right here, but drop those questions in the chat. We're going to see if we get another version. We were doing some zeros before. Outliers of a box plot are how many IQRs above or below the lower edges. So we'll do this last version right here, then we'll do some more work. But the outliers are how far above and below. I was saying earlier that this is a very important number to know. When you're calculating where outliers are, they will be this many IQRs above Q3 and this many IQRs below Q1. So what is the magic number for how far those outliers are above and below? We're drawing it out here visually, talking about the box and how many IQRs you have to go up and down. So what's the magic number for how many IQRs you have to go above Q3 and how many IQRs you have to go below Q1? You're welcome, Victoria. Hopefully you got a 10 out of 10 right there. What is the magic number for how many IQRs? So you take, maybe I'll go back in time right here where I was showing it. There we go. Look at that. So visually speaking, you can see what we've done right here. We are showing it visually. Thought I put them above too. Did I not? I guess I didn't. No, did I? No, I didn't. 1.5, Blake. Great job right there. They're 1.5, and you don't get to see this visually. It goes away. So they're 1.5, and we were talking about that a lot last class. We talked about where the Q3 is. It's the top of the box, so that's at 190 for France. Is it asking France? France, yep. Same question. And then right here, what percent were neutral? That is the marginal display down here. I'm doing the ones quickly that we've already done. Pausing to talk in more detail on the ones we need more detail on. Make sure to move your decimals. And Ava, drop a question. Oh, we got a question right here. Crowd manager monitors accents at rock concerts. Okay. We're going to do a little 474, I believe, next. Then we'll go ahead and do that. What's the probability of a student born in Tennessee being an honor student? Did this one a lot today. And there's that. Move your decimals. And Marvel Hero stuff. Marvel Hero ability flight. So we've done a lot of this. Hopefully people are getting that 100 and also practicing the material. If you're seeing me do one of these questions quickly right now, remember, We do them a lot short. We do them a lot slower when we do them first. Wait, that looks different than the last one. 115 divided by. Maybe it is. Yeah, that's right. And then move decimals. So there we go. Okay, I think we got it. Did we make any errors? No, we didn't. Good stuff. It's 1.5. It's exactly 1.5 IQRs above Q3, 1.5 IQRs below Q1. That's got it. Crowd management, monitors. Okay, we're going to try to get that one in. And we have 2 more questions. Okay, let's talk a little 474. Okay, let me get R up and going right here. And head over here. 51, 55. Let's do this. Okay, it's time for some 474. Let's check this out. So when it comes to paying off a car loan, you have to think about what is happening right here. So I'm going to give some basic questions, but I want you to figure out the math here. We're not going to do some complex math, but I want you to think about what's happening when you pay off a car loan. So even if you're in tool 1, I'm going to throw points if you got this. You're going to go out and buy a loan. You're going to buy a car, right? Your car costs, like, let's say $25,000. Now, you're going to take a car loan out for $20,000. Does that make sense? You now owe $20,000. You're going to then pay it off monthly. So when you're paying it off monthly, you're going to make payments of, let's say, $500 a month on your car loan. Does that make perfect sense? Now, it'd be really awesome if you didn't have to pay interest. That'd be absolutely amazing. Awesome job, Keith, right there. Following along perfectly. So if you didn't have to pay interest, so this is cost of car. This is loan amount. I'm trying to help figure it out, but I want to do the exact work. Sugar's a major. Ooh, might have enough time, Taylor. We'll try to do that. Might run out of time, but we'll try. We're going to go up to as much time as we can do today. But swing by later offstars if you want. We'll throw that one on here. Let me grab it, and we will make sure that's on the list. If we don't do it now, we'll come back. Good to see you here, Angel. So if we don't get that one done, it is on the list of things to complete. So I put it over here. Thank you so much. Drop those questions anytime. Sooner the better. So now you're going to pay. So when you take out your car loan, just repeat to me, I owe them this much. Just repeat to me, I owe them this much. When you take out your car loan, you would say, I owe them this much. When you take out your car loan, you'd be like, I owe them this much right now. Like you just say like, oh, I owe them this much. If you take out your car loan, you'd be like, oh, this is how much I owe them. Don't worry, again, the answer's on the screen for what we're doing right here. If you were to take out your car loan, you would just say, oh, I owe them this much right now. When you take it out, when you're like, I want that car loan, you would say, I owe them, and the answer's on the screen. Amount has 2 M's in it, doesn't it? 3 M's. I owe them this much. How much do you owe them? You'd be like, oh, I owe them this amount of money. That's how much I took out my loan for. Any thoughts on that? See what people say. So the answer's on the screen. We're just doing a hypothetical right here. Like I go out and get a car loan. How much do I owe the bank now? Because I took out that amount. Well, I'm going to pay them $500 a month exactly, but I owe them $20,000. Like that's the amount. Great job, Avery, right there. 100 points. I owe them $20,000, and then I'm going to pay them $500 off each month, right? Does that make sense? So I'm going to pay them $500 each month for my car loan. So we haven't talked about interest yet, but if you were to do this right here, amount with no interest, amount owed after first payment. Now, this is with no interest. This is not how the world works. We need to calculate some interest here in a moment. But how much would I owe next? Like after I make my first payment, how much would I owe? And then we have to think about how to do this mathematically or how with code. How much would I owe after my first payment if there's no interest? And then we have to figure out how to write that and store these objects. Exactly, Avery, great work right there, 100 points. So this is the amount right here I would owe after my first payment. But we need to calculate the what. because there's going to be this. So now we have with no interest. So we're going to need to do some calculations in here. We need the interest rate, right? So we need to figure out, it would simply just be plus interest. So when you're thinking about this and you want to do this, you want to figure out, okay, like what is constant here? Is the interest rate going to be constant? Like when you get a car loan, do they give you a constant interest rate? When they give you a car loan, are they going to give you a constant interest rate? Or are they going to say, I mean, I guess you get a variable one, but I wouldn't. Yeah, usually they say like, oh, your interest on the car loan is going to be 4% interest or something like that. So let's say the car loan has 4% interest. Now, if you're doing it monthly, that interest is going to be this per month. Does that make sense? Like how that would be an interest rate? So if you were to calculate the interest on your loan, it would simply just be this. Does that make sense right there? That is the interest. So we would need to store that into interest and add it on. But is the interest that we have the next month, like when I go to the next payment, so we need to add the interest on here. I'm trying not to do the full thing. I'm trying to give some big hints right here on how to do this. Like you need to be setting these things and using them and writing the first instances and paying off the loan while it's still greater than 0. Hints for that. But with this right here, when you have that, you're then going to have the interest on your current amount. Well, is next month's interest still going to be this amount? Just tell me theoretically, my interest the following month is probably going to be water, because this is what, here it is right here. That is my current amount at month 2. So this is amount after first payment. And that's with interest. Does that make sense? Will there be a study guide for the exam? All the exams have study guides. Let me know which class and I can point you in the direction. You might be talking 201, Jalen. Let me know which class. If you're talking 201, review 1 should have the material. That's for 201 though. Let me know which class, Jalen, though, because I teach 3 different classes. So how would you figure out, yes, 201, up, link right there, Jalen. Thank you for asking, 100 points. How would I figure out the interest that is going to be put onto my loan for next month? How am I going to figure out the interest that is going to be put onto my loan for next month? Because I'll make another $500 payment on this. And then you have to figure out how to do this in code, because we're just solving it mathematically here. And then we just have to assign some variables, work this out, and think about how the code would look, which I don't want to do that or else I'd be solving the exact problem. I'm showing just the math behind paying it off. What is the interest going to be? Because I have to figure out the interest now. What is the interest going to be mathematically here? Does anyone know what the interest will be? What would be my interest on this next month? Like you can tell me what it is or how to find it mathematically. If I have 4% interest, then we have to figure out what. How much interest is this going to have on it? Additional debt. How much interest would this have? Norman, you can say, I don't know if you don't know. That's a fine answer too. But how much interest would this have? So we would take how much we currently have to owe. That's how much we currently owe. Amount owed. And we would, to figure out the interest on it, how would we figure out the amount of interest we're going to get? Like how much extra is going to be put onto this loan? How would we figure out how much extra gets put on the loan? So what could we do? Look at the... What could we do right here to figure out the amount of interest on it? Swings look prettier. Well, maybe. I'd have to take a look. Send me your files, Avery. I'll have to take a look by sending your files, but it looks like it's not being done as a vector over, like, you need to be able to while loop it. You need to make the instances of it and write it out individually. You need to write it out individually right here And sorry, my mom like is FaceTiming me right now. Like my mom is FaceTiming me. I'm just like look down. My mom's calling and FaceTiming. I'm like, Mom, I can't answer this. So don't worry. I wasn't laughing at anything here. I was just like, Mom, really FaceTiming me right now? I almost answered. No, she wants to be on YouTube. But with this right here, this is the amount of interest right here that we have. And notice the interest is lower. So this is the interest right now. Does this make sense right here, Avery? This is the interest that we would have on the second payment right here. So now we would add this interest right here, and this is going to be the interest value right here that would be added to this amount. So there's the interest. Well, we can subtract our payment, and this is it right here. So you have to think about how this works, that you need to be calculating what is the current amount. So at each period, you need to know what it's currently at. You need to know the amount of interest, and then the payment is constant. So these are the things we're working with right here, is that this is going to change. So what changes right here, so we could take the original. So here's the original amount. There's the interest, and here's the payment. So this calculates where we are at after the first payment. And this right here, and we could even put this right here as the value. And you can kind of see how we're referencing certain numbers. This is the current amount owed. This is the interest being added to it. This is the payment we are making. So you have to think about how this works as an equation, where we could also just take and drop this in right here. We're starting to see a pattern to this. This is the key to the problem. The key to the problem right here is you have the current amount owed, current amount times the interest rate, and then the payment on it. And this will calculate what we're at for the next period. So this is going to calculate, we are currently at no payments. Where will we be at after our first payment? So this will be, we've made one payment. Where will we be after the second payment? So this is making your first payment. And I haven't put variables in here, but this is the structure. Is this making more sense, Avery? Because this is a big tip right here. And we went through, and we're not assigning, you need to assign variables to these and, think about how this works. But that's a huge, huge tip right here. Like these are the equations. Because this will, if you just continue this through and you assign variables, you could then start making a vector and continually solving for the next position in the vector until the vector reaches something that is less than 0. So while the tail of the vector, hints, while the tail last element of the vector is greater than or equal to 0, you keep appending to the vector. So that's what the while loop will do. So the while loop theoretically keeps running the code while the last amount on the vector, the tail comma 1, so check your vector tail comma 1, while tail comma 1 is greater than or equal to 0, then we are going to keep appending. Great job, Avery, right there. Good. It's a tough one. It's a lot of work. And so this right here is the structure I would use. I think a lot of people are like finding an equation online that like is not going to work with a while loop. So which is all right. Like we want you to look at things online, but then it might not theoretically work with the way we're coding it, because we might have to code it a little bit differently to append a vector and to make it do what we want. So sometimes it's like, it's not as easy as just drag dropping an equation, which we wish it always was. We always take this equation, drag drop it, and it does exactly what you want. But we're trying to like simulate it with code right here, where someone can put in the values and then append a vector and grow a vector, and we can track the values, because that might just solve, that equation might solve for a certain thing. It might solve for like the amount of time to pay off a car loan at a certain interest rate. But we're saying assign these values, append the vector, and watch as the interest decreases, and then create each element of it as time goes on. Let's do a few more questions right here. Let's head back over. Good stuff. We got time for maybe one more. Let me send out the announcement to 201 because they got a 15-minute till class. 15 minutes till class on 201. Oh my gosh. I think we got time for one more question. Got to go here to watch class live. They've changed the way the streams look. 15 minutes. Announcements. Class in 15 minutes. See you soon. Click here. And there we go. We'll try to do one more speed run it right here. There we go. Send it out. Okay. And let's see. The question was a National Vital Statistics Report. A National Vital Statistics Report. Where is it? I've done this one before, I know. Know the start of some of them. The crowd management one. A National Vital Statistics Report. We got it. Let me turn off the taking questions. Okay, here we go. Time for National Vital Statistics Report. Okay, a National Vital Statistics Report. In this question, we'll be analyzing data with Boxplots, I believe. Let's take a look right here. We got, I like it. We got some histograms. So if you look right here, they've kind of broken it apart into groups right here. And we have the percentages right here from 45 to 49. We've got a little bit of bimodality in this distribution for black right there and white, and stronger left skew, very strong mode right here. Bimodality to the bottom distribution, outlier down here on the bottom side, a little group of outliers down there on the bottom side there. So a lot of interesting stuff with this data. Describe the shapes of these distribution. Both are very skewed to the left. Distribution of white males is uniform and no unimodal. Skewed to the left and unimodal. No, it's not symmetric. The white distribution has one small peak and the black has three. There we go. That's right. How do the distributions differ? They differ in a lot of ways. The range of the distribution of blacks is less. They look to be similar. 1 to 85. 1 to 85. Okay, they have similar ranges. No. So the center for the distribution of blacks is less. I think so. Because the center is going to be best described to where the median is, and the median is going to be over here to the left more. If you look at where the peak sort of is, that's generally a decent idea. Median might be up here for the white distribution, where the black is going to be down here. So the black distribution has a lower median. Center for the is less than, that's good right there. Look carefully at the bar definitions. Where do these bars plots violate the rules for statistical graphs, seeing all that apply? Whoo, oh my gosh. Okay. Interval widths are not constant. We need that. And under 1 year, yeah, that's under the interval widths are not constant. The vertical axis does not have the same maximum. Yeah, we want it to have the same. You generally want the same scales for both. The bins do not cover all possible ages. There are gaps between them. So I think they're treating age. I don't see any gaps unless they're talking about like 79.5, which they'd be really mean to do that. The vertical axis does not start at 0. It's hard to tell. It looks like it kind of does. I'm a little bit scared on that one. It looks like it kind of does. Well, they don't show it, so I'm going to put that. That's mean. Yeah, did they really do that to us right there? They really did that. They really did that. If you got that one wrong at the bottom, please let me know. They're saying it does start at 0, even though they don't show it. That is ridiculous. It like visually it doesn't show it, but it does start at 0 because 0 is right there. That's ridiculous. We have to end with a ridiculous question, of course. But yeah, I immediately noticed some weirdness right here where they're doing like under 1 year. You don't do that. And then the other one right here that they don't have the same vertical scale. You generally want graphics to have the same sort of scales to put them on an even playing field. But that's got it. We'll be back here later doing more questions. We'll find out which questions are crazy, where it has us select multiple things with some subjective answers. We don't like subjectivity here. Brian going off in this chat. Oh my gosh, that question right there is ridiculous. I knew it was this one when I looked at this, and I was like, they should put 0 on that. Like, you should. That is the correct thing to do, is put your 0 right there. Then it starts at 0 technically. So please let me know if you checked this or did not check it and it didn't give you the points. I'll, of course, give you those points back. My Pearson, what you doing? Until next time, bye for now, everyone. Bye!